Seth Husseini. We'll be talking about Swift on the server. Might be the future of Swift. Imagine writing your whole backend in Swift. That would be awesome. I can't wait to be able to do that. Hopefully it happens tomorrow. Next meetup, April 26th. We're going to be over at Boomtown. Hopefully we're here again because we have a... What? Nothing. Okay. We had a little scheduling conflicts. We're back to Quick Left, so super thanks to Quick Left for hosting here again. We don't have anyone lined up for April, so if you'd like to talk about Swift or Swift enums or
disconnected. Okay. Hopefully I can just set that and leave it alone. All right. Okay, so my name is Zeph Husseini. I'm going to be talking about Swift today. Primarily going to be talking about Swift on the server, but we're basically going to explore a bunch of different areas. I'm an iOS developer. I freelance. Right now I'm working for Disney. But we started using Swift in our app the day that we could start shipping apps in the App Store with it. So there was like a beta period before that. But as soon as Swift came out, I really liked a lot of what I saw. My history as a programmer is I started doing some web development during the end of my college years and started getting into programming with Ruby on Rails and was really used to that dynamic paradigm, had no problem with the lack of type system and the lack of type safety. I thought Rails was really powerful and amazing with what you could do with it, and I still believe that. But then after doing web development for a while, I wanted to get into iOS apps. And actually, at the beginning, I was interested in Mac apps. And then when the iPhone came out, I was so interested in it right away. And I had some ideas for iPhone apps, and I was going and asking if you could make an iPhone tuner using Ajax, because I heard like the iPhone can do Ajax. This was back in the days when you could only ship web applications on the iPhone. So I was trying to figure out, can you, like, we've got everything here. We've got all the hardware, microphone, and everything you could need to tune a guitar. So I wanted a guitar tuner app, and I've always been interested in that kind of thing. But anyway, I did Rails development for a while, then got into iOS. And my perspective on Objective-C when I got into iOS was that I didn't really see the value that the type system had and what it gave to me. It always felt like the type system was in my way, and it was just like another thing to like deal with when I'm like editing code, and that really bothered me. I was used to the dynamic nature of Ruby and just the cleanliness and expressivity of the code. And when Swift came out, I kind of figured it out, and I was like, oh, okay, here's the type system. Here's what it can do for you. It's not just in your way, but it's actually here to help you out. So now I've kind of come full circle, and I'm now looking at, okay, can we do web development with Swift? Because I mean, there's a lot of good reasons for that. I think Swift is just a great language, and it's very immature, but has so many great things already. But as we progress, it's just going to improve, and I think it has great merits of its own as a language. And then furthermore, there's some cool potential for sharing of code, and that could look like different things. One way to share code between iOS and the web, or Mac and the web, and things like that, is just in small libraries, and I think that's one of the most promising things is that you can kind of have a set of libraries that you use for development and general purpose things that are useful in many places. And then maybe more a little bit out there that I'm a little more skeptical about is the idea of, sharing code within the same app. So basically, like your web server, you do all your modeling, and then you can just drop that into iOS or Mac and be able to like reuse that code. And I think that's maybe a possibility that I'm interested in. But anyway, that's just kind of an overview of like what I think of using Swift for web development, and we'll see where things go. I'm going to get into some specifics here. I don't have any slides. This is going to be a very organic talk. I'm going to be talking about what's out there in terms of like Swift frameworks that already exist. I'm going to be talking about the open source Swift project and how it's different from using Swift like it's bundled inside of Xcode. I'm going to talk about some specific examples about protocol-oriented programming, which is a paradigm that Apple was really encouraging us to use. And that's sort of a shift from the object-oriented, everything is like inherited from another class, to kind of having more composable protocols that your classes and structs and enums can adopt in order to be reused. And another thing with code reuse is generics. So generics are the idea that you can have a class that needs to reference another class, and the logic about the logic in your protocol for the generic doesn't know what's inside there. It just knows what some of its capabilities are, and that really opens up some new doors. In Objective-C, just like in Ruby, they're both very flexible and powerful languages with some of the same history, like in Smalltalk. But with those, it's kind of, Objective-C obviously does have formal protocols, but there's a lot of like informal protocol stuff going on, especially in Ruby, where you just write to like an interface. You say like, you're going to assume that these methods exist, but you can't be sure that they're there. And then I'm going to rant a little bit against like using string in your applications. Strings are like a great data type. They're used all over the place, but they're used a little too much. And I'm going to show you why I think that is, and what to do about it, and what Swift provides that helps us to avoid using strings so much. And yeah, talk about like Swift on Linux and stuff like that. Yes?
It seems to me that IBM is a big driver in doing Swift on servers. Do we have much visibility into what direction they are headed?
That's a good question. I'm familiar with some of the projects that they have going on, and I'm going to bring up here's their web framework here, and I wasn't really sure like how they do the development here, but it looks like they actively are using GitHub issues, which means there's a lot more like visibility into it than if they weren't, if they were kind of like, developing on their own and then throwing it out there. But it seems like let's see like how many contributors they have and stuff like that. Looks like they have a decent number with some small contributions, so that seems to indicate that there's like community involvement or something. So, but yeah, they are really driving a lot of that.
Okay.
So yeah, as I go, just feel free to jump in. I would have loved to have some like working applications that I like walked you through, but in the past couple of weeks, basically Apple has released their next version they'd released Swift 2.2, and then they'd moved their development branch onto Swift 3.0. So a lot of renaming, a lot of breaking things, and I could have like said like, okay, I'm going to stick with like 2.2, but I decided just to go ahead. And a lot of stuff is broken. I was trying to do some database stuff, and I couldn't get it to work. So I'm just going to show you what it's like, and we'll just code together, and you can laugh at me trying to get things to compile. So, all right. So first, I'm just going to go through a list of like what projects I've seen that have gained some popularity, and what I think of each of them. This is a cool little project called Nest, and the idea here is that it's not actually the code that provides a framework for you to write in, but it's an interface. So it's saying like, here are the protocols that we want you to implement if you're writing a web server or a web application framework. And what that will allow you to do is basically, you prevent tight coupling between web servers and applications or frameworks. So you can take your application code and say like, hey, I'm having a problem with this server. It's like maybe not giving me enough concurrency or it has this problem. And you can just swap it out for something else. And that's one of the really great things about protocols. So I think this is a cool project. There are a few implementations of servers that are Nest compatible. And you can see a lot of like, you'll see a lot of this type of thing where there are, there's just like a router. There's no router here, but you've got a request and you're just returning some content with like a status code and a content type. Basically, a lot of the things that I'm seeing here are very similar to Ruby's Sinatra framework. If you're familiar with that, that's well known for its DSL, which is just kind of saying like get out a path, and then you have a block of code to run whenever a web request comes in that matches that path. So that's kind of like the first phase of the frameworks that I'm seeing. So this is a cool little project. I love that it's protocol based, and it's kind of saying like it's trying to get some consensus in the community about like where we're going with Swift frameworks. The next one is called Swift On, which is Swift on Rails is the idea there. Taylor Swift on train tracks. Here's like where you can see in this and other frameworks, but I think it's like particularly pronounced. You can see like heavy use of strings all over their framework. And I think that's a really negative thing, and it's kind of just saying like, hey, we've got this great language with a really strong type system, and we're just gonna like throw that all out and just kind of like hope that we got the right value in here. So here's like our router where we have a get to to-do/new. There are a bunch of strings here. These strings are like necessary. This string here is referencing something that the compiler should know about, which is like an action called new. So I think this is like one of the places where, there's just one example. We've got a server here. They've got controllers, very much like Rails. You've got before actions. So basically, you can set a method to be run anytime you hit these following actions. So very much like Rails, looks fairly readable and clean to me. The main problem that I have with it is the dependence on on strings. Some cool, like this also exists in Rails, where if you get a request to a certain path and it's an HTML request, we're going to return HTML, and otherwise we want to return JSON as like an API. So this is a cool project. It seems to have a decent amount of following. And then you'll see this stencil templating language, and I think all the frameworks pretty much use this, except for my crazy non-stringy HTML writing framework that I'll show you at the end. And then we've got, middleware is another thing. A lot of people are trying to come to a consensus on like how we're doing it. So middleware is the ability to like intercept a request and do something at that point before it gets to your action. So an example of that would be authentication, or you know, injecting like cache headers, or like if you have CSS file that's at a location, in Rails you'll have it'll like append a query string to the end of it that's used for cache invalidation, and like middleware you could do things like that. It's maybe not the best example, but so that's Swift on. Here's another one called Vapor. This one's inspired by a PHP framework. This one's very active. I think this guy's like the main guy, but there are a couple other people developing it as well. You'll get the same kinds of routing ideas here. I'm not going to spend too much time here, but I'm just giving you an idea of like what all the options look like.
Does all this work in Swift 2 and Swift 3 get dumped on its head when concurrency comes in Swift 4?
It depends on the framework. So this specific framework, they are maintaining compatibility with Swift 2 and 3. And in Swift 2.2, they introduced an operator, or a, I don't know what to call it, but like a pound if, where you can check the Swift version and have different code on each side of the of it, so you can have a framework that supports both within the same branch or something. So they also use Stencil for rendering templates, and I don't really have like a lot of problems with this one. I think it's pretty good. There's one really interesting thing it does for routes. Let's see. Okay, I'm not finding it. Maybe I'm thinking of a different one, but Fluent. I'll just give up in a sec. No, this is the database thing. Oh yeah, so this one has actually like an ORM type thing that handles like persistence and modeling and querying into a database. And I think there are like a couple SQL adapters, one for SQLite and one for MySQL. Anyway, I'm going to move on. Then here's the IBM project. This one seems like very formal in a lot of ways. Like they have pretty good documentation. They have it seems like they have like a more clear direction with what they're doing with it. And that said, I think they also, it's like maybe not as clean of an API in terms of like things you don't have to worry about. An example here is in their router. They have like 3 things that they give you: the request, the response, and the next. So like the next thing is supporting a feature where like it can keep going through the router if you decide in your matching response that you don't want to respond to that, but if you want to like pass that through. I think there's an alternative for doing that kind of idea too. But they've got also adapters for like Postgres and MySQL for doing persistence. And I haven't really tried this one very much, but I think it's probably pretty promising if you want something that's hopefully going to be like better supported than some of the other projects. Then there's this one. This was one of the first ones that came out with like a fancy web page that like talks about how awesome it is. And actually, I think it's like the most underwhelming of all of them. at first they were also licensed in like a really, I think they used like the GPL, and it was more of like a kind of enterprisey focused thing where not really just like open source where anybody could use it, but where anyone could use it for anything. Like you'd have to, meet the licensing requirements, and they'd have like enterprise support. But basically, like you can look around this site, and I just couldn't figure out like what an application actually looks like. There's just like so much stuff to it. It seems very complex, and I'm not really very interested in this project. But they did, I think they did move to like an Apache license or something like that, a little more friendly. And I looked around some of their like database adapters, and they look okay. But I'm not that excited about that. And then here's like my favorite project. It's called Zebo. And this one can be a little bit overwhelming because of the way that it's done, but I think they're onto some really good things. And what I mean by the way that it's done is basically they've got a ton of packages that all do just a tiny little thing. So it's very split up and modular. But it can be overwhelming. So like their application is made of like all these little packages, and some of them are just like 10 lines of code or something like that. But they are they're doing a cool project called SwiftX, where they're trying to actually bring together the community and say like, here's some core standards for writing web application frameworks. And we want you to like all use this code because it's like kind of like the base level of like HTTP status and headers and just like dealing with like how bytes get from like an application like to HTTP through the HTTP protocol. And this was like just created kind of out of Zebo, so it doesn't look like there's much activity at this moment. But they also have a Slack room that I've been talking about a little bit in. I got on because I was having trouble compiling something, and this guy was like, "Oh yeah, I'm working on that right now." He looked at my error and he like fixed it and pushed, and he was like, "Okay, try again." And it was like, seems like a really good community, pretty informal. I had a good talk with them about using some of the code that I had written for handling HTTP statuses, because I had worked on a library for that, and I'm going to see if they're interested in using some of those ideas. And then they also have some higher level stuff. This is like one of their other like main repos that has a little bit more. Some higher level things like headers and cookies and things like that that you need for doing web requests. Sorry, this probably took longer than I expected at the beginning, but we're going to get into like what it actually looks like to write an app here in a couple minutes. But yeah, this was, like I said, one of my favorite projects. And if they can do the thing where, actually the author of Vapor is kind of on board with this like SwiftX thing. I think that stands for like Swift Cross-Platform Standards is what they were saying. But they're trying to like unify some of the underlying code so that people can do interesting things like above that at higher levels. Okay, so I'm going to just move on from that. And then I'd kind of started working on a few months ago my own like web framework, and I put that in quotes, air quotes, because it's like very immature. It's like there's really not that much to it. But I had seen in a lot of the projects some things that I didn't like, and I wanted to try to like revisit the approach to writing these things in Swift. It felt like a lot of these servers just kind of took, like Sinatra and duplicated them in a different language, but they didn't take advantage of some of the cool things. And actually, to their credit, I think I've seen progress in those areas with like moving towards more protocols and like decoupling and less. More reliance on the type system. So I'm going to show, okay, how am I going to do this? Okay, first I'm going to show this like templating framework that we already looked at a tiny bit, but this is basically just a way to write HTML. So you've got a template very much like something called Mustache that's used in JavaScript and a lot of other languages. And then you kind of you create a dictionary of like JSON basically, and then you pass it to the template and render it. And this is pretty much what everybody's doing. There are these filters that you can pass, like this would uppercase the thing, and this is similar to a template language called Liquid that's in Ruby that came out of a website called Shopify, but that's pretty well known in Ruby for anytime you need a template that like a user can edit, and you're not going to give them control over your servers, and like they couldn't, it protects from like code injection and insecure stuff. But this is pretty much what everybody uses for HTML, and that's fine. I don't really have a lot of problems with it besides just thinking it's sort of a hassle to do all this stuff where you like set up a dictionary. You're basically taking Swift data and figuring out how to like map it into this dictionary, and then there's just everything is a string. Like the keys are strings used inside the template and outside, and you really lose like that compiler element to like your views. So that was like one of the little ideas that I had for my framework, which is called Fly. And I really don't have good documentation here, but I'm going to show you what some of the code looks like and talk about some concepts that hopefully you can take with you to like any application development in Swift. So one is just this like decoupling. Really try to use protocols and make things modular. Talking about strings here, and I also have this router that I did that's pretty basic. And the thing that I like about it is you can use it in lots of different contexts. If you say like, hey, I need a router to just like handle requests. Sometimes we need those in iOS apps, and sometimes you need them on a web app, and sometimes you need just like different attributes. But the way that they all work is they have something that gets passed to it and some things that come out of it. And here's like a GET request, here's a path, here's a request and a response and something else. But this is like very specific to their implementation. Like your request has to be their request object, and same with the response. And like in an iOS app, you don't have GET requests or POST requests. So I wanted to figure out like how can we write a router that's completely generic and that can be reused in multiple contexts. I've got my HTML builder idea, a little command line tool that I'm toying around with to help like build and run projects. Yeah, another thing that I saw in some of these frameworks is a lot of people were using like any or any object, and I said like that's throwing out type data. Of course, the type data is there, but it's only there at runtime. So it takes a lot more work in your Swift code to figure out what that type is and figure out how to deal with it usefully. And then there's a lot of subscripts. Subscripts are when you have like brackets. Usually use it for like accessing a dictionary. So you have your dictionary and then brackets with a string inside, and that's going to match the key. And you can do some really cool things with subscripts in Swift. You can pass like multiple arguments to subscripts and even named arguments. But there's a lot of like subscripted strings that are, not using that type safety. So I guess like the first thing I'll do is show you my little framework. Okay, I've got it here. Sorry. I've been like really redoing how I'm do all this stuff, so I'm kind of confused. I'm trying to figure out where I'm going. Okay, so yeah, and then one of the things I wanted to do is have it more of a higher level framework. All these other things are just kind of like giving you the pieces to build your web application, but they're not giving you like tools to do that with. So I'm going to run Swift build here, which is going to just compile the application, and then we get an executable here, and I'm going to run that executable. I have my little kickoff thing, and we're going to go to localhost 8080, and we matched a root here. So let's look at like what this code looks like. So first of all, like in a Swift package, I probably approached this from the wrong direction, but in a Swift package, like you've got a sources directory where you have your code, and you've got like a package file that declares your dependencies. So I'm just saying I'm depending on my Fly framework. It's on a local path in this case. And then I'm also depending on this HTTP for Swift server. And in my, I have a lot of stuff that's just like commented out here. But in my, do I have something simpler to show you? Okay, let me just delete some stuff for a sec. Here's like my main file. So what we're doing is we're setting up an app. We're gonna like set up a server, which I just have like a, this file here is just a wrapper around an open source server that I found online. And then I'm gonna start it. And then in my actual application itself, is this big enough? Okay. I'm doing some of the same stuff that everyone else is doing, where you just kind of like root different things. I have like something defined as an action, which is just saying like this is what it's going to take and this is what it's going to return. So you can either pass a named action, or you can pass a block. So I've got just some random stuff here, and I'm going to show you what happens when I hit a 404. So here's a 404, and I can see this in my log here. I can see all the requests that come through. So this is like something that I don't think is really provided by other frameworks, like the kind of logging as you get requests, formatting those, and then certainly things like this are the higher level features that I thought would be cool, is when we miss a match, we mismatch a route in development, we show this like route list. And then I can click on any of these GET requests. Here's one that is using like a Bootstrap template around it, and I'll just show you what that looks like. My little HTML builder is called SwiftTML, and I built this template in that. Let's take a look. So basically, here's my SwiftTML view. What I wanted to do is kind of have like a nice DSL for just like building up your HTML tags. So it starts out with just like an HTML tag. If I, well, I've got this helper called HTML5, and like what it lets you do is like pass the elements you want for the head and the elements you want for the body. And I just have these like methods that are named as like HTML tags. And it's a little weird. This is like not a standard thing you would do in Swift, but it kind of lets you have like a nice API for saying like, here's my content. I have a link helper that like wants a URL string after it, and you can kind of like name things nicely. And you can also do, basically in Rails, there's some HTML building helpers that can take content either at the beginning or at the end in a block. So if you have like multiple elements that you want to return, you usually put those at the end. So I can do that here. So I'm gonna like delete up to the 2 there, and I'm gonna like return like a list of things here. Hopefully this actually works, and I'm like, yeah, I'm not just doing something that's totally broken. So we're back here. Here I've got 1 and 2, and they're right next to each other because there's no white space in this generated HTML. Actually, I just realized that I think this is not going to work like I'm wanting it to, but let's see if I can get it to work. But I have this, I have something where, this is kind of inspired by a Ruby library for writing HTML, where you kind of just put like the names of the tags. This would like expand to an ID of content, and the dot would expand to a class of name. And this is kind of like a popular way of doing like shorthand annotations for HTML building. So I kind of wanted to like use some of those concepts, and they do a thing where, like, if you need white space, you have these operators. Let's see. You have these like operators to say like, hey, I want some white space before this, or I want some white space after this. I think this is actually going to not work because I don't have it. I know what I'll do if this doesn't, but I think I don't have those operators like built into my current repo, but I'll figure it out. But the idea is that if you did this, it would put white space after, or you could put white space around it like this, or like this. So we're using some of Swift's, what is it called, operator overloading. We can define custom operators. I don't think that's operator overloading. I don't remember. But anyway, so this is like the idea behind my HTML builder. I think it's elegant in some ways where like if you wanted to just create like a small snippet of HTML, it could work really nicely. And then even in a larger context, you can do that with abstraction. So like I've got this Jumbotron, which is like, Jumbotron is like a Twitter Bootstrap thing. So they want like a div with a class of container, and then inside that one with Jumbotron. And I can just kind of create my own helper here and pass my own data into that. What else was I going to say about this? One thing interesting about this is like there's not really a mechanism for making tons and tons of, for like kind of like templating methods in Swift. So in order to implement this, I used, I like generated a file that has like the definitions of all these. So really the app, the framework itself is like built around this tag class, which is not actually a whole lot of code. We're almost done. Here, that's pretty much it. It can do things like, these are all called void elements in, oops, the small screen is a little tricky. Any self-closing element in HTML is called a void element. So like a break or an HR. So basically, the way you would make a tag is you just go tag, and then you put anything here. And in HTML, anything is valid. Like I can put my own named thing, but I could also put div. And then I can add attributes like classes or something called attributes, which would let me say like style equals something. I would do that just by going so I could do like background color or whatever I want here, and that would like output that. Or I can do like data. So if I want HTML data attributes, this would generate something that's, this would generate like data thing equals true inside the HTML tag. So it just gives you those kinds of things. And then every, here's my stuff with like adding white space before and afterwards. And I've got those alias to these like bracket operators that I was trying to use. And then we have a generated file where we have all these like names, all these definitions of these things that all return tags. So when you have a SwiftTML template, it's just a list of tags that are like nested inside of each other, and then it can render out into a real view. So just got tons and tons of those, and then some of them are customized, where like for link, I want an attribute named href, and I want it to be called to, and I need to have a target, or you can have optionally a target, which is like target blank opens up a link in a new window. And same thing for image. We've got source and alt. So we basically have like a way to customize special tags. Any questions about this kind of thing so far? So basically, the things I like about this, like I said, are that you can generate code in like a type-safe environment, and this is used in the router for Fly. So let me show you like this is to like generate my my 404 page. Oh, I killed my server. So here's some HTML. It's not pretty right now, but basically we're in a framework. I just needed to like make a little bit of HTML. There's no need to like have like all this structure where you have templates in separate files and generating your like data like when you can do it inline. Let me open up a playground here in a sec, and I'll show you what I mean about this generic, some generic stuff. You'll notice I've been like doing everything in Vim. That's one of the things is like right now there are ways to like make open source Swift work inside of Xcode, but it's not really super easy, and I've tried a couple times, but I gave up, and I just kind of like been doing things in Vim. So you lose your like auto completion, but I like Vim. So basically, here's like my route class. I forgot that we're in Xcode now. I need to maybe too big. I don't know. Let's try this. That might not give us enough context. So I have a route class. I don't want you to worry too much about this, but what I'm going to show you is like how you use generics and protocols together. So basically you're saying, here's a router, and it has something called a route inside of it. And the route has to conform to a protocol called request handler. So let's see what request handler is. So I just tried to like find the symbol. Oh, you know what? I think I need to, no, I am. Okay. I should be able to find that, but it's not. Anyway, here's my request handler protocol. And it's going to tell us what we need to have in here. We need an associated type called a request, and that needs to conform to a protocol called routable. And all that means is it just has a path. And then we have an associated type called response, and we have no constraints on that. That's all left to the developer. We need like a path for the route to match. So that's saying like, here's your path, or even one with like interpolated values. I can show you here. Like I can kind of put whatever I want here, and that's gonna get thrown in. And then it has to have a respond function. And then here are some methods that are already implemented. You don't have to implement them because we implement them in this extension, but you can implement them if you want to override them. So if you wanted to change some like matching logic, you can implement this valid match function and return a bool on whether it's valid or not. And then here's like implementation of our request handler that's built into the framework. You don't have to worry about what that is, but that's just saying like everything that's a request handler is going to get this logic. So anyway, back up to the top. We have a router, and it just needs to have like a request handler associated with it. It's got a bunch of like methods available to it, and you don't really need to worry about it. But that doesn't do anything by itself. What we need is we need to like have something that conforms to request handler. Request handler is, route, because if I try to use, this is what I'm looking for. If I try to use a route, it's going to tell me, well, let's see what it tells me. It's going to tell me an unresolved identifier. That's not like a particularly helpful error message. I was expecting it something like it saying that it needs, its associated type. But I'm going to show you like the simplest version of how to use it. And we can actually have a router that just takes a string and returns a Boolean with what we've built here. So I'm going to extend string so that it conforms to routable. You don't even have to make your own type. You can extend existing types and make them conform to protocols. So then I'm going to create my own route. And in the protocol, it said it needed an associated type. That was a new keyword. It used to be called type alias on both sides, but now it's called associated type in your protocol. So this is just saying that I want my request to be a string and I want my response to be a Boolean. And some pretty basic stuff. This is just going to say, like, I want to be able to do something inside here. So this is saying, like, I want to take a request, I want to take some parameters, and I want to return a response. And a response is just Boolean. So I could put bool here, but and then what I want to do here is actually use my router. So this is, I'm calling it string router because it's a router that is for matching strings. And I'm going to register some roots here. And I told it to print, but nothing's printing. But that's just because I only created my roots. I didn't actually do anything with them. I can show that, like, I've registered some roots or routes. I don't know how to say that. Depends on where you're from. So nothing's really happening here. I think I have this set to, like, run automatically. Okay, there we go. So it's showing me that I have something routed to home and something routed to create. And then I can, like, handle these. And these all print all my stuff out. Yeah, I don't know why this is going so slow. Anyway, so okay, there we go. Yeah, and one of the things I wanted to have it take is I want to have it return some parameters. So what I had it do is create a dictionary of strings and return that to the action. So it's kind of like the simplest thing you would need. It'd be totally appropriate for use in an iOS app where you're doing deep linking. And then, but we have these strings, so, like, I don't really like that. So I was talking to you about how I hate using strings. So I'm going to talk about, like, a kind of paradigm for matching and extracting data from these kinds of things in a type-safe way. So here's just like a transformer class. It's also using generics. So it's saying, like, here's the data type I'm getting in, and here's what I want to give you back. It can be reversed, but we don't need that right now. And then I have two little tiny structs. One is called a param parser. Really, the only reason I have this struct is because I want it to have a name that's readable, so you know what it is when you're looking at it, instead of just taking a string dictionary and returning a result. And then this is something. Every parameter, like, that we get from a URL is a string. So I know that it's a string, so I can put that here, but I don't know what type I want back. So what I'm going to show you is, like, using some higher level types inside of our parsing. So we're not just dealing with strings all the time. So here I have an enum called action. I'm just using, like, the sign up idea as a placeholder. You would normally have, like, a different route for each one of these. But I'm just going to say, like, here are the three things that I want to match. And here are the strings that represent the enum cases. And I'm going to create a transform here. And what it does is it gets in an optional string. Or no, it gets in a non-optional string here. And it returns something called out, which is a generic. So the Swift compiler knows that it's an action. And it's actually an optional here, because raw value, when it fails, it will return nil. And then I'm going to use my param parser type. I'm going to like create a type alias, and a type alias just represents a different data type. So it's really good for just readability, for, like, helping you understand what you're doing. If you're dealing with a bunch of strings, you might want to just type alias them to something that's more, sorry, I'm, like, not typing very well, to something that's more meaningful, that, like, expresses intent in your code, so it's readable. So here I'm saying, like, this is user action data. I want an ID that's an integer, and I want an action that's from this enum. And I can define all my parsing here. What I'm doing is I'm just getting a string. I'm going to see if it casts to an int. If this fails, we're in a guard statement, so we're just going to return nil. And then here I'm doing the same thing with an action.
Earlier you said that type alias had been deprecated or gone, or went away.
Yeah.
Or has it been?
Type aliases are still used, but they're not used anymore in protocols. So in protocols, they're called associated types to show us that like this is something that's associated to what you're doing.
But they're legitimate in other places.
Right.
Okay.
So anyway, we're almost through this whole thing. Thanks for sticking with me. Hopefully this is interesting. So anyway, we're gonna like return this tuple, which is an integer, the ID, and it's an action here. And if any of this fails, we're gonna return nil. So it's not gonna match that root. So what that lets us do is we're gonna register a route, and I'm saying I want an ID and an action, and I'm gonna handle this route. Is this set on manually? Yeah. Okay, so it says we matched the user action route, and we have 1, 2, 3, 4, and sign in. So that's like an actual action object. You could fetch something out of the database in this way too, and like just return a 404 if you don't have anything, without even hitting your action, just within the route, within like the parser. I guess you're hitting your action, but you're not. Anyway, and then if I have something here like watch doesn't make sense in this context. So nothing happens. I mean, it should return false here in a sec, but anyway, so that's like our simplest version of the router. I'm gonna try to be more quick about this, but I'm gonna show like how we use this in a smarter way when we need HTTP requests. So here I'm gonna define like a fly action type alias, which is just a tuple of a request and a response, and it returns a response. I'm going to make my requests routable by conforming to a protocol. They already have a path method, which is all they need to be routable. So there's no implementation needed there. But here I'm doing the same thing. I'm creating my type aliases. I'm adding a method here because we don't have a method when we're doing our iOS just like string router, but we do in the web context. And then in our respond thing, okay, here's the first thing. I showed you that we have a wrong file here, Xcode. So we have a default implementation for valid match, which is just true. So I didn't have to deal with that for my string router, but inside this, I have I want to make sure that the method is correct. So basically this allows you to extend the router, do whatever logic you want with it. Here I can actually attach parameters to the request if I want to like put those in the request object instead of saying like here's your request, here's your response, here's like an extra array of parameters. And then I can actually do something else cool with it, which is extend it. I'm extending my router, but only for only where the root, which is an associated type, is HTTP routable. And I'm adding a couple methods. Like here I added like an alias for get, so I can add routes in a different way. Here I'm making a new protocol that is called HTML printable. And here's where I use my little SwiftTML thing. I'm just extending my router with this SwiftTML class, and that's what makes these methods available. They look like they're like classes or structs, which would make them globally available, but I want them only available where I actually need them, so it's not like muddying up the namespace or the global namespace. So it gives me a place to implement this method. I'm generating a little bit of HTML, and I'm just mapping these into list items inside a larger list. So I think this is like pretty clean compared to setting up a separate template depending on strings to hook them up and not really having that compiler safety. And the cool thing is if somebody doesn't want to use my router, all they have to do is conform to HTML printable root, and they can get the same kind of 404 behavior. So I'm saying you can use my router anywhere, and you don't have to use my router. So this is like what's really great when everybody just kind of goes in on protocols, and you can switch out libraries and get new behavior. Here's kind of a better example of like what a view should look like. In my like Jumbotron thing, it was like really messy, and I was like, this is like hard to read. But here's like a view, and what you would do is you would create it and pass in the data that you need for it. So this could be a model with whatever properties you need, and then you can use your data where you want it. So I'm checking that it's a GET request because I don't want to link to posts or deletes. And I'm returning a link for GET requests. And besides that, I'm just returning a path. So that's just a quick look at like generics and protocols, how to extend protocols. It's cool that you can declare constraints on your extension. So here I'm not extending every router, I'm only extending certain types of routers. What else do I have? I guess I should wrap up. It's been probably almost an hour. Oops. Almost. Does anybody have any questions or comments?
Do all these frameworks deploy the same way? I mean, in terms of you're running your own server? And do any of these support, like, say, for instance, AWS Lambda deployment?
Good question. Yeah, I actually wanted to get into that a little more. Feeling like pretty scattered at the moment. So I've been like, yeah. But that's a good question. So for deploying these things, here, let me go to swift.org. There are only 3 supported places to run Swift right now. People have like already had pull requests out there for the Swift project that allow you to like compile Swift for Android. But at this moment, there's just Xcode, which is just Mac, Ubuntu 15, and Ubuntu 14. So pretty much the way everyone's doing this is in Docker. I was going to show it running in Docker. I could try to get that working if you guys want. But basically, anywhere that you have Ubuntu, you can run it. People have, I think, gotten it to run on Heroku. I'm not sure if anyone's done Lambda or if like you can just have like Ubuntu running there.
I hack out there. Somebody was calling it from a Node.js system call.
Mm-hmm.
But you know, it's like you could do it, but it wasn't really.
Okay, but the way they basically work is like you have your dependencies like in here. These things have to, support Linux if they do, and otherwise you can only run it on the Mac. I wanted to talk about this a little more, but I didn't really get to it. I'm going to go to, let's see. Okay, so I just wanted to go to an old thing where I had like everything thrown in one place. I didn't have stuff. I guess I had some stuff extracted at this point, but trying to see where I have. Okay, this is the kind of thing like if you want to support both things, like you have to know what code you have available to you. Some things are available in some places and some places aren't. Some things aren't. I am relying on Foundation in some places, and that does work on Linux. But you can include Foundation, but you don't get everything yet. You just have like what they have working. So if you call something that's unimplemented, you'll just get like a runtime error. I'm not sure if they have it at compile time.
Who's doing that porting?
Apple as well as the community. So so I went too far here. Let's try Foundation. Okay, I'm just going to go to their main page. Here we go. So we've got 94 contributors who have already worked on Foundation. These are probably Apple people, but a lot of people with just minor contributions. So people are welcome to come in and start doing things. They're doing some cool stuff. Like in Swift 3, we're getting out of this join with separator Objective-C kind of thing, and we're gonna start passing like named first arguments. So this was just me getting rid of some some of the Swift 2.2 method calls and going to 3. So instead of create directory at path, we have create directory with an argument at path. Same thing with data. Swift uses pattern matching, so when you have different name, you can have multiple functions named data, just like in Objective-C you can, and like the rest of the method signature is what makes it unique. Split with a separator argument. Anyway, so these are some of the changes that are already happening in Swift 3. Any other questions? Anyway, so if you are interested in more, I'd love to hear from you. If you want to talk to me about it. Let's see. Yeah, so I'm Zephus on Twitter, and I've got a bunch of these up here. The things that I think are going to be kind of like useful going forward is I think I like my I like the HTML builder for certain purposes at least. I think it's sort of like experimental from my perspective. Like I don't know how it'll scale, but I expect that like as Swift gains a little more features and like flexibility in certain ways, that it could work out nicely. I guess I was going to show you this really quick. Well, it's okay. Anyway, if you want, just check out some of my stuff on GitHub. The thing I want to point out about this library, I won't show you exactly how this works, but it's a really like simple, basic use. It's just saying like I need to return like 200 OK, but there's actually some like cool things you can do with Swift to make that really nice. And I looked at a bunch of implementations of HTTP status, and I didn't really like them, so I figured out like how to do it in a nice way where you can just say you can assign like to a number with integer literal convertible, and you can omit HTTP status because it can infer types, even though this is not an enum with cases. But there's some cool things when you get into just like knowing what protocols Swift has to offer, like equatable, custom string convertible, hashable. There are just all these little protocols that let you like, do different things. So hashable lets you use your object as a dictionary key. That's not really new. It's like same in Objective-C, but anyway. So thanks for listening.